Multi-material 3D printing lets us combine the properties of different materials like color and flexibility into a single object that is printed all at once. However, objects with many materials are difficult to recycle. Each material has a different processing temperature, so they must be separated for recycling. In this work, we present a computational fabrication technique that enables recycling of multi-material 3D printed objects. Our approach generates dissolvable interfaces between different materials in an object without affecting the object's intended use. When the interfaces are dissolved, the object is disassembled into its individual materials and can be easily recycled. Our computational design algorithm has two main processes: interface generation and interface cutting. For interface generation, a user imports an existing 3D model as meshes that specify different materials. The algorithm then uniformly scales and intersects different meshes together to find regions where the two meshes meet. The result becomes the basis of the dissolvable interfaces. The intersection regions are then shrink-wrapped and thickened to produce plain dissolvable interfaces. To increase the attachment strength between different materials, our algorithm can generate different slot joints, like mushrooms on the interfaces. After an interface is generated, it may extend beyond the original input geometry. To fix this, our algorithm performs interface cutting. During this process, the interface is cut by being intersected with the original input meshes. Then it is subtracted from each input mesh to produce cut input meshes. These meshes and the cut interface meshes are then exported as STL files for 3D printing. To demonstrate our computational technique, we processed and fabricated 9 objects that have different structural, functional, and aesthetic qualities. Their interfaces are printed with water-soluble PVA. At their end of life, these multi-material objects are submerged in water, and their interfaces dissolve to enable disassembly. We show that all 9 of these objects fully separate and enable us to recycle 89.97% of their total mass, leaving only the dissolved PVA behind. As a whole, our technique promotes greater sustainability in 3D printing without compromising an object's functionality. For more details, please see our paper. Thank you.